Now in this video we're going to look at how to apply bearings onto some maps. Now here is this example from your textbook. This is from the Yeppoon Great Keppel area, and so the question that you want to do is measure the grid bearing from Monkey Point to Double Head on this particular map. Now before we go any further, I want to talk about this thing called grid bearings. And you can see here these grid lines have been drawn on the map, and they roughly go north-south. Now they're not exactly north-south, they're drawn parallel to each other like they are going north-south, but lines on a map like this do not actually travel that direction, because these are the lines of longitude that you'd find on a globe of the world. And of course lines of longitude, if you have a look here, it's a pretty dodgy done globe. Lines of longitude start from the North Pole and travel all the way down to the South Pole, and they all start in the north, they all end in the south. And so you can see here the lines are not parallel, they're curved. They all have the same origin and they all have the same finishing point. Some of them go out a little bit, some go a long way, so there's no way that those lines are parallel. It's those lines there, the lines of longitude, that are drawn here on this map. But because it's drawn over such a small section of small area of the Earth, they draw them parallel just to aid with the diagram. They're not actually parallel, so these lines are actually not true north. So any directions or any bearings we get from these lines are called grid references. So going straight up the page, this is what we call, it's not true north, it's close, we call it grid north. It's what the lines are drawn to be going at, but they're not exactly true north-south. So we want to get the bearing going from Monkey Point to Double Head. So they're marked in here, here's Monkey Point, there's Double Head. And they put the ruler on there, that's what you can see there. Now, because it's going from Monkey Point, it's travelling this direction. So clearly, we know that north is where we start and we rotate around in a clockwise direction. So once we rotate around to here, that's 180 degrees. Around to there is 270, so we have an angle that's bigger than 270. So how are we going to work it out? We actually don't need the protractor to be right on Monkey Point. Anywhere along that line's fine, because everywhere along that line is pointing at exactly the same angle, so it doesn't matter where it is. So they've got the protractor here lined up on this particular grid line, and you can see the crosshairs there. So that line there is the north-south line, so that's 180 degrees there. What we need now is the size of this angle here. If we can work out the size of that angle, add it on to 180, we've got the bearing that we're after. So we read along our baseline. This time our zero's on the inside, so we're reading off the inside numbers. It's coming around to here. There's our grid line there, and we can see that the angle is, that angle, 103 degrees. Because I need to travel this way, there's 180 plus an extra 103. You can see here the grid bearing is the 180 for the north-south line plus the 103 we measured, 283 degrees. So they're the type of questions you're going to get. Be able to read a map and work out grid bearings. Now, next question. You can also measure distances on maps. You'll see down the bottom here there is a scale. This one is the 50,000 scale. Now the question says, find the distance from Strathpine to Albany Creek. So here's the Strathpine station, here's the Albany Creek post office. So they've been marked in for you. So you get your ruler out and you measure it. And from the ruler you can see here that on the map it's a distance of 82 millimeters. We now go to our scale. Our scale is 1 to 50,000. So 1 of any unit on your map is going to equal 50,000 of exactly the same unit in real life. So since we have 82 millimeters, that 82 millimeters must happen 50,000 times that out, that many mil, convert it down to a more reasonable number, so that distance is 4.1 kilometers. That's the second style of question you're going to get. Now, moving to our third type here. Once again, from this Great Keppel map, find what geological feature is, and gives you a distance and a bearing. So this particular question is now taking the last two elements and putting them together. is taking this one here on bearings, taking this one here on distances and putting them together. So on this map you've got to travel a distance of 26.75 kilometers on that particular bearing from Monkey Beach. So find Monkey Beach. Now, first of all, the distance, 26.75 kilometers. So once again, we go to our scale. Remember, it's 1 unit on the map is equal to 250,000 units in real life this time. We've been given the real life distance, so we've been given this 250, so we've got to go back the other way. So instead of multiplying like we did on the last example, we're going to take our 26.75 kilometers and divide it by 250,000. Now, the author of the book's done a few in between steps. They converted the 26.75 kilometers into millimeters, then divided by 250,000 and got a distance of 107 mil. So they set the ruler up at 107 millimeters. Now we have to find a bearing of 262. I'm just going to jump off the textbook for a second and show you what they've done. Here I have something similar set up. The Monkey Beach is marked, the 107 mils is down here, and it's going to travel on a bearing of 262 degrees, which means from due north at Monkey Beach, rotate around 260 degrees. As I said before, the grid lines are all parallel, so it doesn't matter if I use that grid line there or this grid line here. This line is always traveling at the same angle. So you'll see the protractor isn't placed on Monkey Beach, it's just placed somewhere along that ruler, because everywhere along there the line's traveling at 262. Now, 262, what they've done is, obviously that's 180 degrees, we just need to measure this angle here. If you have a look on the diagram, they don't have the protractor here on the underside of the ruler, they have the protractor on the above side of the ruler. How are they going to get around this? Well, one of your laws you would have remembered, hopefully from grade 9 or 10, when straight lines intersect, this angle here, which we want, is exactly the same as this angle over here. So if we go back to the diagram, even though we want this angle, we're going to measure this angle, because they are exactly the same size. And then we're going to take our 180 and add on whatever that is. If we go back to the map, you can see that's what they've done. We want this angle in here, but the protractor is set up to measure the exactly the same angle over there. And on the baseline, 0 is on the inside, reading off the inside numbers, 82 degrees. And you can see that's what they've done. There's the 82 past the 180, put it on the right angle, and then your 107 mil brings you to around about Mount Wheeler. So that is a combination of the previous two examples.